another way to think about how these probabilities work together. This is a more visual approach, looking at probability trees. So trees work on probability branches. Um, and what you do is you set up each step in the process. In the example with the Coke and Pepsi, we might set up which team you liked first, and then set up the probabilities of how much you're likely to like Coke versus Pepsi. But let's do a simpler example first, where we have three events. We're going to toss a coin, and then we're going to toss another coin, and then we're going to toss another coin. Okay. These are independent events. Let me get a pen up here. So these are independent, meaning that what happens on the first coin toss does not influence the second one. So we toss a coin, we start over here at time 0, and we toss a coin, and we have 50% chance that it's heads and a 50% chance that it's tails. So 50-50 heads or tails. If the first one lands on heads, then there's a 50% chance of the second one being heads and a 50% chance of it being tails. And that's true whether the first one lands on heads or tails. So it goes 50-50, 50-50, heads or tails. And then depending on what the second one does, then we toss the third one, and it also is either heads or tails. So heads or tails, heads or tails. Okay. So this defines three different paths. This path, we get three heads, 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 and it's 0.5 times 0.5 times 0.5 is 0.125. This path is a heads, then a heads, then a tails. All right, so this is heads and a heads and a tails, but its probability is also 0.5 times 0.5 times 0.5 is 0.125. This one is a heads and then a tails and then a heads. So still two heads, but in a different order. 0.125. This one, now this one only has one heads and then a tails and then a tails. And it's also 0.125. Okay. Now here's the other one with two heads. That gets a tails first, but then it has a heads. Then it has a heads. And then this one has tails, heads, tails. Okay, so that one has two tails. This one has two tails and one heads. And this one is the only one that has three tails. Okay. Now we can summarize this with this little table. There are these things called combinations, and so a combination is unique. So this is three heads, this is two heads, one tail, this is one head, two tails, this is three tails. And remember, there's only one way to get three heads and one way to get three tails. But there were three ways to get two heads and a tail, and three ways to get two tails and a head. The probability of any particular combination is 0.125, but there were three what we call permutations, which is rearrangements. So while each one had a probability of 0.125 altogether, if we multiply that, we get 0.375. So 0.125 here, 0.375 here, 0.375, 0.125, all adds up to 1, just like all the 0.125s there add up to 1. Okay, so the end probabilities have to add up to 1. So this is a case where the outcomes were independent. let's do a case that's more like our Packers and Vikings, where they're not independent. And so suppose there's a 50% chance that you will eat dinner at Cutter Ziskin and a 50% chance of eating at King Scales. All right, so this starts off the same with a 50-50. Okay, 50% that you end up here, 50% you end up here. But if you go to Cutter Ziskin, then there's an 80% chance that your new friend is going to join you for dinner, which means there's a 20% chance that they're not. Whereas if you go to King Scales, there's only a 15% chance that your friend will join you, and there's an 85% chance that they won't. Okay. So now, out here, what we have is the probability of CZ and friend. So we multiply the 0.5 times the 0.8, and we get 0.4. Or CZ and no friend, 0.5 times 0.2 is 0.1. Okay. Notice the 0.4 plus the 0.1 adds to the 0.5. Over here, the probability of KS and friend, 0.5 times 0.15 is 0.075. And KS and no friend is 0.425. Notice these two also add to 0.5. And if you add all four of these over on the right, you get 1.00. Okay. So how does this relate to the probability of A given B being related to A and B and B? All right. So let's rewrite this probability of friend given CZ would be the probability of friend and CZ over the probability of CZ. Okay. Now here, the probability 0.5 is the probability of CZ. So that translates to something over 0.5. The 0.8 here is a conditional probability. It's the probability of your friend going if you go to CZ. And notice that condition is different if you go to KS, right? So that's actually the front piece. So the probability of friend given CZ is 0.8. And then the and is what you get out of the end, friend and CZ. And so that is 0.4. All right. So what you did to get this and is you rearranged this equation. You did the probability of B times the probability of A given B, and you got the and condition at the end. All right. So sometimes these are easier for people to see when you're setting these up. You need to pay attention to where the conditional goes. Also, there's a supplemental coding file to show you how to make these trees in R if you want to.